Hi, this is Amir Arzani. In this presentation, I'm going to show you how to make nice visualizations of vector fields for visualizing fluid flow data. So we are going to look at the data generated by the open source software package SimVascular. So I'm going to load the data. So this is the aorta and the thoracic aneurysm. So now you're looking at the pressure field. Can change this to velocity. So I'm going to specifically focus on how to visualize vector fields appropriately, specifically for presentation purposes, as well as creating nice and effective figures for your papers. So the way we visualize a vector field in ParaView is by using the glyph, which is the filter here. So if I apply a glyph to the data, you can see that this is what happens. So the vectors are huge. So under information, I need to make sure the orientation array is velocity, and I need to scale it by velocity 2. And then I can see that these vectors are very big. So you can scale them down. And this is what you can see. So now you can see that the problem with this type of visualization, I can turn off the main model too. So here I'm looking at the vector field. I can color it based on velocity. So now the problem with this default visualization, which I see in many presentations and papers, is that the big velocities are huge. They're shown with huge vectors, and the smaller ones with smaller vectors. So you cannot really see the entire data vector field very well. So if you play this, you can see that even it gets better. So it gets worse, right? So the vector fields get huge during the peak of the flow. So now you might say, okay, what if I scale it further down to something like this, right? So when the flow is maximum, I can have something reasonable. So perhaps I can scale this to a smaller value. So this is fine. This looks good. But now the problem is that when you play this, you can see when the velocities get smaller and smaller, you don't have any flow in the parts of the domain where the vector fields are small, because you're scaling it based on the magnitude. So now, in my opinion, the best way to do this, visualize vector fields, is to normalize the vector field. So what you can do is that you can use this calculator filter here in ParaView to normalize your vector field. So here, I'm going to call the resulting array field vel norm, and I'm going to apply the normalizing operator. So here you can see you have multiple mathematical operations that you can do on your data. So specifically, I'm going to use norm, parenthesis open, and then I'm going to select my velocity, which is called velocity. And then I can close the parenthesis. You can also type this in as well. Then I'm going to apply. So now what I'm going to do is that I'm going to apply glyph on this calculator data. So if I do that, I have to make sure that I'm scaling it by vel norm, the new array that I created. And now I can see that I can color it based on the original velocity. So the nice thing is that here I'm showing these vectors scaled by the normalized vector field that I created, but I'm coloring them based on my original data. So if I rescale the color bar, so now you can see that we have a vector field that's consistent, meaning that in every location, the length of the vectors are the same, and the color bar shows me the magnitude. So the color here shows me the magnitude. So I have both the magnitude information of velocity vector and also the orientation information, and I don't have any of the issues before about just vectors getting too big or too small. Okay, so and now and then if you want to create nice figures for your paper, you can turn on the original model. You can color it by solid color, and you can make it opaque. So if you go under information properties, there's styling, opacity, you can reduce this to something like perhaps 0.2. Now you can see that you have your model and also the vector field. And you can make the vector field a little bit smaller as well by reducing the scale factor. So if I do that, here you can see that I have a nice visualization where I have the vector field inside the model, and I can see both the 3D model as well as the vector field inside it in a consistent manner. And if I play this for different time points, you can see that it remains consistent. Okay, now the next thing I want to show you is how to create streamlines appropriately for figures. So to generate a streamline, we use the stream tracer filter. So I click on my data, I apply the stream tracer filter. And then what I'm going to do is that I'm going to, under properties, select the seed type to be a point cloud. And I can see that I have this sphere. I can move this sphere. Ideally, you want to place your sphere at the inlet of your model. This is where you're seeding particles and integrating them to create these streamlines. So here's where I'm going to have this to cut at the inlet of my model. And then I'm going to turn off the show sphere option. And now what I'm going to do, I'm going to color the streamlines based on velocity. You can color them based on any of the arrays in your data that you want. And you can see that I need to increase the length of the streamline. So if I scroll down in properties of streamline, there's a maximum streamline length. This is the maximum length that you will be integrating essentially the particles to kind of like trace out these streamlines. You can increase this so your streamline goes all the way to the end. Now, this is fine. This is a typical way that I see people create streamlines for visualizing their data in ParaView. But what I recommend to do is to go one step further. So if you want to make a truly amazing and visually appealing streamlines, you can go under filters, then you can go under alphabetical. So here is all the filters that you have in ParaView. And now you can apply the tube filter, which what it does, it gives thickness to your streamline. So what I'm going to do here, I am going to select a radius for my tube. So I'm going to select 0.04. Okay, I'm going to color it based on velocity. Okay, so now you can see that we have a much nicer visualization of these streamlines, and you can clearly see these helical flow patterns, these tornado type vortices in your flow. And this is an extremely nice way to visualize them by giving this tube type feature to your streamline. If I show you here, you can see that it's a pretty amazing and nice and cool way to visualize your streamline data. So I'm going to play this further so you can see these nice helical flow structures, these vortex patterns that are going to be visualized very well with this technique by using tube. Okay, so you can see the quality of the visualization. So I recommend you create streamlines by using this feature to give them a nice a pattern that could be visualized much better than the way it is originally. You can see this is the original visualization, which in my opinion, when you do this in presentations or figures, it might not show as well. But if you do the second approach, you can see that the structures could be visualized in a much nicer and more enhanced way. Okay, so now the next thing I want to show you today is how to visualize now 2D vector fields. So what I'm going to do, let me bring the so for visualizing 2D vector fields, I'm going to be using this filter, which is called the surfaceLIC filter. So for this one, you have to delete your data, first load the filter and then load your data. So what I'm going to do, I'm going to go under edit, I'm going to do reset session. So this deleted basically resets my session. Now I'm going to go to tools, I'm going to go to manage plugins, and I'm going to load the surfaceLIC filter. So these are some more advanced filters you have in ParaView. So now that I loaded, now I can go back and load my data one more time. Okay. Okay, so now I have my aorta and the velocity field. Now I want to create a slice because I want to visualize a 2D cut through the domain. So if I slice my original model, I want to move the slice such that it's at the center of my aneurysm, somewhere here perhaps. Apply. Okay, so this is what I have. I have a 2D visualization of my aneurysm. Right now you're looking at pressure, but I can also look at velocity. Okay, so this is a contour of velocity. And this is how you would see people typically create contour plots, right? You just have a 2D slice through your 3D data, and you're coloring it based on things like velocity, magnitude. And I can, of course, change the color bar as well. So if I go to edit, if I click on edit color bar, and then I can change it to a rainbow pattern as well, which typically looks nicer. Now, I want to show you a much more nicer way to visualize this data. So now that you've loaded the surfaceLIC, you can click change the visualization from surface to surfaceLIC. And now you can see that we are showing the streamlines here. And you can see it's a pretty nice way to visualize the streamlines in an automated way. And of course, you can still improve this significantly. So if I go to properties under the slice that I created, now I have some new options under surfaceLIC, and I can select the enhanced contrast to be LIC and color. If I do that, now you can see that we have this beautiful visualization of our 2D contour field where I'm showing you the streamlines. It's an automated, optimized, very nice visualization of streamlines. It only works on 2D for 2D vector fields or surface vector fields. And I'm also coloring it based on the magnitude. So if I play this, you can see that we have this amazing way to visualize our vector fields in 2D. Okay, so you can see these nice recirculating patterns in the cross section that I created. Okay, now we can also do this for wall shear stress vector fields, which is something, wall shear stress is something we're particularly interested in cardiovascular flow modeling. So let me turn this back to surface. Now, if I load my VTP set of data, which is SimVascular generated, so these are where I have my surface data, I have wall shear stress here. So here you're looking at the wall shear stress magnitude. And this is typically how you would see people visualize wall shear stress in presentations and papers. But I'm going to show you, again, using surfaceLIC, how to really get the most out of your visualization. So if you change this again to surfaceLIC, now you can see, in this case, nothing happened because under properties, I need to make sure that my vector for surfaceLIC is selected to wall shear stress. Okay, now I'm going to also go to enhance mode and then similarly do LIC and color enhance. And now you can again see that we have this amazing way to visualize our surface vector field, in this case, wall shear stress, which shows us these streamline patterns of wall shear stress. So we can see all these interesting topological structures in the wall shear stress vector field that are created here. So you can see all these nice fixed points, these different types of fixed points and different types of manifolds that are created in the wall shear stress vector field. So my group has extensively studied these features, and we've shown that how these manifolds in the wall shear stress vector field and fixed points are related to things such as near wall transport. But this is essentially a very nice way to visualize your wall shear stress vector field, because you're not only showing the magnitude, but you're also showing the vector field behavior, the directional behavior, and also the topological structures. And this is streamlined, so it doesn't tell you if a vector field is forward or backward, but you can similarly use a glyph and add the vector field on top of this as well. I recommend in this case, you normalize the vector field again, just like we did for velocity, and you can color it based on a solid color this time, because you already have the color from the surfaceLIC. So essentially you can create like black normalized wall shear stress vectors and just plot them on top of this to also see the direction. Okay, so now I'm going to give you a little bit comments about creating figures as well. So if you want to create a figure, nice figure for your for either presentations or for your papers, obviously you want to use a white background because that looks better. So you can use a white background. And then what I recommend is that you definitely, for this color bar, so what I see people when people create figures, either in ANSYS or in ParaView, is that they use a default color bar text. So what I recommend is that you actually get rid of the color bar. You also get rid of this axis here. So have something like just the domain that you want. You can, reduce the white space to only contain your model. So something like this. And what I recommend, you save a screenshot here. So file, save screenshot. And if you use, you have different formats you can save. And if you save a figure here, and then I recommend you also save the color bar separately, without any text. Okay, so just the color. So just get rid of the text, which you can do in the options here, and just save the text separately. And then in a separate software, such as Inkscape or any other software that you use to create your figures for your papers, to put panels next to each other, for example, you add the color bar separately, and then with text, you type in the information, such as the range of the data and the array that you're plotting. You're going to create a much nicer visualization this way, because the text will be searchable in your PDF file. It will have a much better contrast. You can change the font size easily, and you'll create much more professional looking figures, as opposed to just taking these that are hardly visible when we read paper, especially when these things are created in Fluent. Again, with Fluent, you can also do the same thing if you're using ANSYS. And by the way, you can load ANSYS data as well in ParaView. So if you're generating data in ANSYS, if you export it in a specific format, then ParaView can also load that data. Okay, so now the next thing I want to show you is how to visualize volumetric data. So if I go back to my original data, so let's say I have something like pressure, and I want to visualize this. There's a nice feature in ParaView that allows you to visualize data in a volumetric fashion. So essentially visualize 3D scalar fields. So if I click on volume, you can see that my screen went black. So now I want to tell you this, that in my computer, this version of ParaView does not work with volume rendering on my computer. And this is something that I've always had issues with ParaView over the past several years. So if you see that you want to use a specific feature on your computer and it doesn't work, do not give up on ParaView. So the combination of your computer version as well as the ParaView version could be causing this. So in my case, what I'm going to do here is that I'm going to use ParaView 4.0. So let me launch ParaView 4.0. And I'm going to see that in my case, ParaView 4.0 works. So here's ParaView 4.0. I'm going to go in and load my data again. Okay. So here's my data. And now I'm going to select volume rendering. And now you can see that I can visualize the pressure field in a volume rendered fashion. So this is a pretty cool way to visualize your data. So now if you want to do this for velocity, if you select velocity, you might see that it does not work for velocity. What you have to do is that you have to use a calculator to turn the velocity field into a scalar field before you apply the volume visualization. So let me do that. So if I, let me see, if I apply calculator, call it result, I'm gonna do mag. So mag is calculates the magnitude, velocity. Then I'm going to press apply. Okay, so now I have the result filter, which is the result array created under information, which is the magnitude of my velocity. And now I can apply volume rendering, because volume rendering needs a scalar data. So now you can see that I'm visualizing my velocity vector field in a volumetric fashion. And you can see the higher values give you higher contrast, the lower values give you lower, or rather opacity, lower opacity. So now one thing that I often find useful with this volume rendering is that if you click on edit color map, by default, the way it works is that it gives the highest opacity to your maximum range, and 0 opacity to your minimum data. Sometimes it's used, and what you can do is that you can add control points, and this is something I need that it's often needed, and you can move up the opacity of the lower end of your data. Then if you click apply, you can see that you're also seeing this lower value data that might not be visible. So if I go like this, apply, you can see that the lower range of my data is not visible. But if I play with this, I can change that to based on what I want to see. So for example, these branches are now better visible now that I did this. Okay, so I hope you liked this video, and I hope you use these nice features in ParaView for creating visually appealing figures for your presentations and papers. Thank you.